Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be starting Section 6 of Chapter 1, which is studying compound inequalities. A compound inequality is an inequality that is formed by the union or the intersection and of two simple inequalities. While you do not need to copy this definition for a compound inequality, you do need to understand that a compound inequality is basically solving two inequalities at the same time. And once you solve those two inequalities, you graph the two answers on the same number line. Now, when we look at those two inequalities, the two inequalities could be joined by the word or they could be joined by the word and. So if we take a look at the inequality below or, we have an open circle at 2, and then that's shaded to the left, and we have an open circle at 4, which is then shaded to the right. So what we would say if I were to write an inequality statement for this graph is I would say that x is less than 2 or x is greater than 4. So I'm using or to say that it's less than 2 or that it's greater than 4 because it can't be less than 2 and greater than 4 at the same time. In contrast, if we look at the graph below and, for this one, I see that there's a closed circle at 1 shaded to the right, and I see that there's a closed circle at 6 shaded to the left. So for this graph, it's kind of bounded between 1 and 6. So if I were to write an inequality statement to go with this graph, I would say x is greater than or equal to 1 and x is less than or equal to 6. Now, when you use the word and, we could write two separate inequality statements, but since this can happen at the same time, we can be greater than 1 and less than 6 at the same time. I can write this as one single compound statement, and this compound statement is going to be when I have x in the middle, and what I'm going to do is use the 1 and 6 to show my bounded point. So I'm going to have x less than or equal to 6, but x is also greater than or equal to 1. So what this second statement is telling me is that x is between the values of 1 and 6. So this is a second way to write this, and when we do examples, we'll see it written both ways. So I wanted to show you both ways to write it. Our first example is to solve and graph the compound inequality 5x minus 7 is less than 13, or negative 4x plus 3 is greater than 11. So when we have compound inequalities, what we're going to do in situations like this is solve each inequality separately. So the first one, I'm going to draw a line down my inequality symbol and solve this for x. So 5x minus 7 less than 13. I'm going to first want to add 7 to both sides to get that 5x and 20. And then I'm going to want to divide by 5 on both sides. So I'm going to have x is less than 20 divided by 5, 4. Now, once I've solved this inequality, I then want to solve the second inequality. The second inequality says negative 4x plus 3 is greater than 11. So I'm going to draw a line down my inequality symbol. I'm going to subtract 3 on both sides. So I'll have negative 4x and then 8, and then divide by negative 4 on both sides. So I'm going to have x, 8 divided by negative 4 is negative 2. And then the golden rule of inequality says anytime you multiply or divide by a negative, you have to flip the inequality symbol. So since we divided by negative 4 on both sides, we need to make this x is less than negative 2. So my two statements are x is less than 4 and x is less than negative 2. So my next step would be to graph these two solutions. So when I graph my solutions on the number line, I have x is less than 4, x is less than negative 2. So at 4, I'm going to put an open circle, and then I'm going to need to shade to the left. I usually just shade a little bit until I see how my complete graph's going to look. And then I'm also going to have x is less than -2. So that would be an open circle at -2, shaded to the left as well. So really, this is just like one big graph shaded all the way to the left. I don't actually have to put the open circle at 2 because the first inequality was x is less than 4. And if it's less than -2, then it of course is still going to work. So one of the common misconceptions is that there's always has to be 2 parts to the graph, but as this example shows, that's not always the case. You should always have 2 inequality statements, but the graph might be able just to be one statement because they're both going to be less than the number. So our next problem says solve and graph the compound inequality -3x plus 2 is greater than -7, or 2 times the quantity x minus 2 is greater than or equal to 6. If you feel like you can try this one yourself, pause the video and try it. Otherwise, keep watching to see how it's done. So when we have 2 inequalities, what we're going to do is we are going to solve each inequality separately. So I'm going to start by drawing a line down the inequality symbol and solving this inequality for x. So my first step would be subtract 2 on both sides to get -3x with -9, and then divide by -3. So we're going to have x, -9 divided by -3 is +3. And anytime you divide by a negative on both sides, we must flip the inequality symbol. So our first inequality is x is less than 3. The second inequality we're going to solve. First, we need to distribute the 2 to both x and -2. So this will be 2x minus 4, drop down the 6, add 4 to both sides. So 2x with 10, and then divide 2. So you have x, you have 5, and bring down the inequality symbol greater than or equal to. So our 2 statements, x is less than 3, x is greater than or equal to 5. And then we want to graph the solution on the number line. So when I graph x is less than 3 on the number line, that tells me I need to put an open circle at 3, and then I'll be shading to the left. Again, I usually just shade a little bit to start, and then I can finish the whole graph at the end. And then my other one is x is greater than or equal to 5. So that would be a closed circle at 5. And then we would be shading to the right. So for this problem, we have 2 different directions going on. X is less than 3, or x is greater than or equal to 5. Our next example says solve and graph the compound inequality. -36 is less than 3p minus 6, which is less than -15. So this is a type of AND problem in which one giant inequality is given that we need to solve. So when we do this, we're going to focus on the middle because that's where the variable is. And we're going to get, in this case, the variable p all by itself by solving like we would normal equations. So this one's slightly a little bit different than what we have seen before because it's like 3 in 1. So I'm going to draw a line down both inequality symbols. And then I'm going to focus on the middle, 3p minus 6, and ask myself, what would I first get rid of if I were solving an equation? Well, I would first get rid of the minus 6 by adding 6. Now, the difference here is that it's not just 2 sides. This is kind of like 3 sides to a puzzle. So we need to add 6 to all three pieces, the left, the middle, and the right. So negative 36 plus 6 is negative 30. Drop down 3p. And negative 15 plus 6 is negative 9. And then again, go back to the middle where you have 3p. We want to divide everything by 3 to get p by itself. So negative 30 divided by 3 is negative 10. You're left with p in the middle. And negative 9 divided by 3 is negative 3. We divided by positive numbers, so we're just going to drop down the inequality statements. So we have negative 10 is less than p, which is less than negative 3. In other words, our values are bounded between negative 10 and negative 3. So we need to make a graph to represent this. So when I go to graph this, I have negative 10 is less than p. So I'm going to put an open circle at negative 10, and then I need to shade towards the direction that negative 10 is less than certain numbers. Well, negative 10 is less than the numbers to the right of it. So again, I'm just shading a little bit. I will finalize my graph shortly. And then the second part says p is less than negative 3. So that would be an open circle at negative 3. And we need to shade towards numbers that are less than negative 3. So that's going to be to the left. So I see if I were to shade, this is going to be everything in the middle between negative 10 and negative 3. So I really like these types of problems because it tells me I'm always going to be between the leftmost number and rightmost number. So open circle at negative 10 and negative 3, and then the solutions is everything in between. Our next problem says solve and graph the compound inequality. Negative 12 is less than or equal to 7x plus 9, which is less than 16. If you feel like you're ready to try one on your own, pause the video and try it. Otherwise, keep watching to see how it's done. So, for this problem, when we have 3 and 1, what we're going to do is draw a line down both inequality symbols to split this into our 3 parts. And we're going to focus on the middle and think, how would I get the variable by itself? So we have 7x plus 9. The first thing we would want to do is get rid of the positive 9 by subtracting it. And since this does have 3 parts to it, we need to make sure we are subtracting it from all 3 components. So negative 12 minus 9 is negative 21. The middle is just going to have 7x. And 16 minus 9 would be 7. At this point, the next thing that we're going to want to do is we're going to want to get 7 gone with the x, so we need to divide by 7. So negative 21 divided by 7 is negative 3. In the middle we have x, and 7 divided by 7 is 1. We do not divide by a negative 7, so we're just going to drop down the inequality symbols. So we have negative 3 is less than or equal to x, which is less than 1. So once we get the inequality statement, we then want to graph it. So when I graph this, it says negative 3 is less than or equal to x. So that means we have a closed circle at negative 3. And I need to shade towards number that negative 3 is less than. So that would be shading it towards the right because that's the numbers negative 3 is less than. My second part of this statement says x is less than 1. So that's an open circle at 1, and we need to shade towards numbers that's less than that. So that would be shading towards the left. So you can see that this tells us our numbers are bounded between negative 3 and 1. It's an open circle at 1 because of your inequality less than. And it's a closed circle at negative 3 because of the inequality symbol less than or equal to. All right, our next example is to solve and graph the compound inequality. X plus 8 is greater than or equal to 9, and x divided by 7 is less than or equal to 1. So I'm going to solve each inequality separately. So first things first, x plus 8 greater than or equal to 9. I'm going to subtract 8 on both sides to have x. 9 minus 8 is 1. And then I'm going to drop down greater than or equal to. For the other inequality, I need to multiply both sides by 7 to get x. 1 times 7 is 7. And then drop down less than or equal to. So I have x is greater than or equal to 1 and x is less than or equal to 7. So now we need to graph it. So my first statement, x is greater than or equal to 1. That tells me we have a closed circle at 1. And I need to shade towards numbers that are greater than 1. So shading towards the right. And then the other one is x is less than or equal to 7. So that's going to be a closed circle at 7. And then I need to shade towards numbers that's less than 7. So that's going to be towards the left. So we can see that we are bounded here between 1 and 7. We are either larger than 1 or less than 7. And then close circles at 1 and 7 because it said or equal to. Our last example says solve and graph the compound inequality. -2 times the quantity x plus 1 is less than 4, and 4x plus 1 is less than or equal to -3. If you'd like to try it yourself, pause the video and do so. Otherwise, watch me and copy in your notes. So, first thing we're going to do is draw a line down the inequality symbol and then distribute the -2. So -2x minus 2 with the 4. Add 2 to both sides. So we have -2x with 6. And then divide -2. So we have x. 6 divided by -2 is -3. And then since we divided by -2, we need to flip this to be x is greater than -3. Our second inequality, we're going to subtract 1 on both sides. So 4x with -4. And then divide 4. So x with -1. And this is going to stay less than or equal because we divided by +4 on both sides. So we have x is greater than -3 and x is less than or equal to -1. So we now need to graph our solutions. So first, x is greater than -3. I'm going to put an open circle at -3, and I need to shade to the right because that would be numbers greater than -3. And then the second one, x is less than or equal to -1, tells me a closed circle at -1. And then I would need to shade to the left to get numbers less than that. So right here, we have an open circle at -3, a closed circle at -1, and then we are shaded in between because we need those greater than -3 and less than -1. So this concludes our lesson on Section 6, Compound Inequalities. If you have any questions, please feel free to ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.